So I don't know. Let's just y squared minus 2y plus 1, right? Plus 10 equals 91. And then you have to distribute. I deleted the question, so I can't remember exactly what he was asking for. Negative 5 plus 10 equals 91. And then you subtract a 91. So you'd have negative 5y squared plus a 10y. That's a horrible 10y. And then negative 5 plus 5 is, or 10 is going to be a positive 5. And then minus a 91. So that's going to be a negative 86 equals 0. That just doesn't look like a fun problem to be able to use during the box method. You could do it, but it just, I'm assuming, looking at this, but I don't know why you would take this problem. I mean, you could just subtract by 10 and then, like, I don't know. I'm not sure if you're on it. I'm not sure. I can't remember. I was seeing if you had this, but I mean, like, I wouldn't factor this. I wouldn't solve this by factoring. What I'd basically do is just subtract 10. Subtract 10 on both sides. And that'd be an 81. And then I'd divide by negative 5. Well, here you're going to get some complex numbers, right? So y minus 1 squared equals whatever 81 divided by negative 5 is. And then you take the square root. So y minus 1 equals plus or minus, right? And then you square root on the top is going to be a, so let's see, you're going to have a 9i over the square root of 5 plus or minus, and then plus 1. So y equals a 1 plus or minus a 9i over the square root of 5. So then you could just go and write that in the factored form. But yeah, as far as, yeah, so trying to do the factoring, that's probably why you got stuck trying to factor that, because yeah, factoring under those is going to be very difficult from that regard. But what you can do is solve it and then go ahead and put it back in factor form if that's what you needed.